Hello all, welcome to Dapp Mentors YouTube channel. So my name is Darlington Gospel, and previously we worked on a 6 hours plus course on basically a crash course on Rust development. Okay, the things you needed to know on how to familiarize yourself on Rust development, the syntax, all the basic structures of Rust development and the things that you're going to need, venturing into blockchain as a smart contract developer, either for Solana, ICP, Polkadot, and every other blockchain network that uses Rust as their smart contract programming language. So that particular course served as a foundation for the subsequent courses on Rust development for smart contract that we're going to be building on this platform. So if you haven't gotten in touch with that, I will really recommend that you consume that content first. And today's content will be based on the knowledge that you already have on that. And I'm not starting this as a beginner, okay, even though it's going to be beginner friendly for those that have already taken that course or you have some knowledge on Rust already. If you have that, that is a good bonus for you, okay. So but if you don't have that, I would really recommend that you watch that video first before you come into this. So in today's video course, we want to dive deep into Rust development in the Solana ecosystem. And the Solana ecosystem utilizes a framework to build their smart contract that is built on Rust as well. And the name of the framework is Anchor. Okay, so we're using Anchor framework to build Rust smart contracts on the Solana ecosystem. That is what we are trying to achieve in this section. And then for this tutorial, we'll be building a Dapp called Voti. Okay, so this Dapp, in this particular part, we're going to only focus on the smart contract development. I'm going to teach you about how to build smart contract in Solana ecosystem. Okay, so we're getting everything from scratch, installation, every single thing that you need to do to get Rust, Solana, and Anchor framework installed on your computer, and then we'll write the smart contract for it. And not only that, I will teach you how to make sure that you don't have errors in it, and also we'll test out that smart contract, write some tests for it so that we can verify that our code is functioning the way we intend for it to function. And not only that, I will show you the tricks that are involved when you're programming for Solana. It's not like the way you're going to see it when you're programming on Solidity. Okay, it has a different ideology altogether. So I'm going to break it down for you. And I'm also going to show you how to refactor your code and separate your code into multiple files. So we're going to be using multiple file structure at the end of this program. That is like the last thing I'm going to do to finish up this. Then on subsequent one, we can then translate that we can hook it up to a front end where we can use the buttons and the web interface to interact with our smart contract. So that is what we want to achieve in this particular section. So I hope you're pumped for this particular build, and if you're pumped, please hit that like and subscribe button. If you're new to the channel, please do so. Hit the like and subscribe button. We really need every encouraging effort that you put into making this video and this channel more publicly accessible and seen by concerned people. All right, so with that said, we're going to jump into the tutorial. And don't forget, my name is Darlington Gospel. You can hit me up on Twitter or LinkedIn. We can connect there. All right, so let's jump into the tutorial. So here is what we're going to be building in a nutshell. This is just the structure of it. And in this structure, we're going to have polls, okay? Polls, and we have candidates that will register to that poll, and we have voters, okay? So let me explain this in detail. A poll contains information such as the ID of the poll, okay, description, the day that that poll starts, that you can start voting on that poll, and the day it ends, and the number of candidates that register that are going to be there for people to vote. So these are the various things that a poll does contain. All right. So, and each poll has candidates. Okay. This is a candidate belong to a poll. A poll has many candidates. All right. So you can see here a candidate. We have a candidate ID, and the poll which is associated to that candidate. Okay. The poll ID which the candidate is associated to, and the name of the candidate, the number of votes that that candidate has, and if this candidate is registered. Okay, this is very instrumental for us to perform some checks later on. All right, and before I proceed, you should know that we have a counter, state variable that we keep track of all the number of polls. All the polls, give us like a total number of polls that we have in the platform. So this keep track of it. That's what this normally does. So for each poll that is created, this counter is going to increment. That is what it is. And a candidate has, each time a candidate is registered, the number of registration also goes up. It's similar to this. So the number of registration goes up. So these registrations keep count of how many candidates altogether in the platform, and this count is used in determining the candidate ID. Just like with this count, this registration count is used in determining the candidate ID. Just like this counter count is used in determining the poll ID. So that is how we worked on it. And so remember, a candidate has many voters. Okay, so this is a voter right here. A voter has information about the candidate. A voter has information about the candidate they are voting for. So this is the candidate ID. So this is the candidate that they are voting for, and this is the poll ID. Okay, this is the poll that they are voting in, and the voted status. Okay, say has this voter voted? Yeah, true or false. So it's a Boolean. So a candidate has many voters, and a voter belongs to a candidate that belongs to a poll. Okay, so that is just the reference. That is just the story, in full, in short. So, but there is some things that you should know about the Solana blockchain that I find quite interesting. Coming from someone that has been working on Solidity for a while, and I've built several different platforms and smart contracts on Solidity, I find the Solana ecosystem a little bit more interesting. Not like too interesting than Solidity, but I find it fascinating in terms of how data are stored, the storage idea, the idea behind the storage of data. Now I'm going to explain to you, but we're going to see it in code later. So for example, each time that I create a pool, that pool is stored independently on that Solana blockchain. So it's different from any other pool. You get that, and it has its own, address. So I could use that address to track that pool on the Solana, blockchain. It's not like I'm putting all of those things in one area and all of them are there. No, this is not how it is. It's actually this pool, this one pool is on its own, is existing on its own, and you can track it down. The way you use in tracking that particular pool, or how it is found on the blockchain, is through what they call program derived address. You're going to be having an encounter about this thing called program derived address. Each time that you create a pool, there is an address. You understand, an address that there's an address that is created along with it, okay? And that address is it's just like a regular Solana address. So let's just say that each time a pool is created, something like this appears. So something like this, okay, this is a program-derived address that points to this pool specifically each time that a pool is created, and that can be tracked on the Solana, Explorer. You can see information about that particular address that was generated. Okay, this is one interesting thing about so you can literally track one pool by this, which is really cool. You understand that? And at the same time, it is still linked to what's it called, the rest of the pools that are going to be created. So there's still a relationship that can help you to fetch all of them. Okay, so this is one fantastic thing I found about that. So each time I create a pool, it is independent. Okay, each time I create a candidate, every single candidate can be tracked. We have a program-derived address. Each voter, each time a voter votes, that vote has a program-derived address. You can track that vote as well and have information about that vote. So everything is completely, dismantled, and decentralized. You understand? It's not combined together, which is really cool, and the ability to bring them all together as well is just great. So I wanted to let you know. And how does a program-derived address generated each time that you create any one of these entity, a poll, a candidate, or a voter? How it happens is through a thing called seed. You understand? There's a seed structure in Solana smart contract creation. So this seed determines what this string, this PDA, this program derived address is going to be. So I'm all talking in theory right now, but I just wanted to bring that ideology into you so that when we're coding, you see what I meant. When we're coding is very important, so because this got me a little bit confused at the onset, but then when I started diving deeper and deeper, I was able to decode, put it all together and understand the relationship and how all these things they work. So with that said, we're going to now jump into installation of Rust, Solana, and Anchor framework, and also create the project. So for installing all of these things in your machine, you follow this procedure. Okay, this first step is quite important because you use this to install Rust. Okay, and this is for Mac users. I think if you just visit the Rust website, you'll be able to see everything, even instruction for installing on Windows, so you can have it installed here directly. So this is the same instruction, and other installation method is also available. I think it will be much better if you install using, this is other installation method if you're using Windows. Okay, so Windows users, there is a whole procedure, for you to install it on your local machine. So, but I'm just going to follow the method, which is just straightforward, as documented in Solana website right here. Okay, so you go to solana.com/docs/intro/installation. That is how you get this particular step-by-step instruction for installing this on Windows, on Linux, and on Linux-based system, basically. So that will include Mac OS and Linux itself. Okay, so you copy this line, and paste it on your local machine, and also run this particular step, which is here. All right, and you run this. So all of this should be I'm not going to be doing that part, because I already have this thing installed on my machine, so I don't want to uninstall anything. So so if I say Rust, C dash dash version, okay, so I can increase this and bring it here. Okay, so this is what I'm just doing. You see that I have Rust installed already, but what I did was to just run this command here, all right, to get all of them installed. So it's just pretty straightforward. So when you have Rust installed, you can confirm that. You see I have the same version, almost the same version. So no, mine is a little bit bigger, just by one. So that is it. Then the next thing you need to install is Solana CLI. Now I already have Solana installed here. So instead of me trying to skip everything, I'm just going to install it freshly on another computer on the web, which Gitpod kind of helps you to do that for free. So I'm just going to come here and create a Gitpod URL. But please, let's select a repository. I'm going to go to this repository. Let's say GitHub, this empty. All right, so let me copy that. So Gitpod is having a little bit of, an issue right now starting up. So I can't create a fresh one, but I can use the one that I created like yesterday for testing purposes. So to do that, you just need to come to this workspace and open the existing one that I have. So I've opened it here. You can see it's just an empty directory. There is nothing here. And you can see there is really nothing in here, just an empty project space, because the purpose of me doing it is just for teaching purpose. You don't need to go through this process. So what I want to do is I want to use that to install Solana, so I'm going to bring it here. Okay, yeah, Gitpod is having an issue right now. So I'm going to come here. So the instruction that is provided, this is how you install, Solana. So I'm going to copy that line of code. Okay, and right now if I run, the cool thing about Gitpod, it already has Rust installed. So if I do Rust C, dash dash version, I don't need to install Rust. So Rust is by default installed right here. Okay, so then, but I would need to install Solana because Solana is not yet here. So if I do Solana dash dash version, it's not existing. So I will put this line of code and execute it. So this could take a while. So I'm going to get back to you once it is completed. Okay, so the installation has been completed. You can see that statement, but if I still run Solana version, is still not recognized, and you look at this, close and reopen your terminal to apply the changes, to apply the path changes, or run the following command. So you just run this command, so I'm going to run that here, copy it and paste, and now check for Solana. You can see that Solana is installed. If I run that, see, this is a version of Solana that I have installed. Anchor is the next thing that we need to install here. So to install Anchor, we come here. Even that instruction is written here. You can see that. So we're done with that. So we can run this. If you need to update to a newer Solana version, but we just installed the latest one, so we don't need to do that. So you need to then install AVM. So AVM basically is Anchor Version Manager. Okay, so and you use Cargo because Anchor is literally a cargo package built on Rust. So if I copy this line of code, or just do this, copy this line and come here. If I do AVM dash dash version, we have AVM installed already. I probably came default, but this is how you install it. You have to run Cargo, but you should also know that Cargo is also a package that comes with Rust. So if I do Cargo dash dash version, is that Cargo is installed. So Cargo is a package that came with Rust, is a Rust, package manager, just like with NPM. You understand? So we are basically installing. This is how you install AVM and you run that. So it's gonna get all these things and have it installed. Probably why that AVM showed up was because I had previously installed it, maybe or maybe not, maybe because I installed Solana. I don't know for sure, but you have to go through the process. So the process says install AVM, so we're installing that AVM. So the installation is complete here, and the next step that you want to do is to check this version. Okay, so by running AVM dash version. So I'm going to run, I think I've run that before. So AVM dash version, you can see that particular version is installed, and once it is installed, you need to install Anchor. So because if you do Anchor dash version, you see it doesn't exist. Okay, so since it doesn't exist, you have to install it. Okay, so you have to use it. So you see this install the latest, okay, and then you use it. Okay, so that is what it is. So let's run that first. Let's install Anchor. So run this, and it's grabbing the latest, and let's have it be done before we proceed. All right, so that finally has been installed. So at this point, we can use it. So because we still say, okay, it's already in use. So, but how you do it is, if that doesn't work for you, just make sure that you say use latest, okay? And when you run this, you can see it's now using Anchor version this already. So when you run that, so you can see Anchor is up and running. So this is exactly the same place that I am on my own local machine. So if I do Anchor dash version, okay, you can see I also have Anchor installed here. So we are all caught up, and from now I can peacefully install this on my own local machine. So I did this so that you can flow with me. So at this point, let's create a project. So let's create the project for it. We can open this on the terminal. Let me open this on the terminal. So I can close this one, and I can increase this. So I'm gonna see a little bit backward. So I'm inside this folder here. So while I'm here, let's create an Anchor program. Okay, there are like two ways to create this Anchor program. And the name of this program, I want to call it Voti. Okay, so that will be the name. I already have Voti 1, so I'll probably just rename this so that it will not, Voti 1.0. So to create that, we need to run npx. So please, we're running this. We're not just only installing. We're not only packaging the Anchor program, but we want to use Next.js templates so that when we're translating it into Dapp, a full Dapp where you have the front end and all of that, it can just flow well without, having to copy some code down to another project anymore. So everything will be in one piece of project. So say npx create, and of course, you know that this works only if you have Node.js installed. So this npx create Solana, create Solana. If you're wondering how I get to know this look at this. This is what it is. Create Solana Dapp. So this is the package that is responsible for that. You can see that here. So, and what it does for you is to install. You can install Next.js plus Tailwind, no Anchor, or you want to use Next.js plus Tailwind plus Anchor Basics, or Next.js plus Tailwind plus Anchor Counter. So we can have all those things installed. So I'm just going to run that piece of code here. So let's come back here. See, okay. All right. So nps create Solana Dapp, and you run that, execute that. So it's going to ask for the project name. So we're going to call it vote. All right. So this is the project name, and want to use Next.js, not just React. So we're going to also use Anchor basic example. Should we use that? No, let's use basic example. Okay. And so it's going to clone the repository and then have to install the npm packages and all that. So we'll have to wait for a while. So the installation is complete, and you can see what happened. Clone the project into that particular folder. You can see installed Vibe, npm executed, the initialization script, initialize the repo, and basically got everything done. So if I do ls, you can see that vote right here. So if I want to open it in VS Code, I say open vote, and that would be opened on VS Code. I'm gonna increase that a little bit. And please, there are some certain extensions that you just need to be aware of, okay, that I have installed. You can see this thing that is going on, this performance, this process that is running under the hood. That is because I have this extension called Rust extension pack. So which is this? This is it right here. So it's installed. So this Rust extension pack contains things like the Rust language analyzer, which was what was running there. We have crats, and we had orthodox string. Okay, so we installed those couple of extension packs that are being used to manage our package, manage our framework. So here's the Anchor project, and if you look here, it has this part belongs to the Next.js application, and then this part is where the Solana contract or the program is going to lie. All right, so we can, because we have Node.js installed or Node model installed already, you can do npm run start. Okay, so run dev. So this is running here. So I'm going to copy this and come to the browser. So you can see that. So this is our application. Just a dummy stuff going on. This is just created by that one piece of code that you just ran. So everything is ready. Okay. So, but of course, we're not going to be diving deep into the front end in this part. We're going to be coding some hardcore smart contract stuff. So that's what we're doing in this section. So, but before that, I would like to explain some basic things you should know. This is, of course, this is GitHub, and this is Next.js. It's none of your business. None of these are your business. Don't focus on them. And this node module, ignore them. All right. So this is Anchor folder where the program runs, and this is migration. You will not be concerned about that for this time. You have this, source. You're not going to be concerned much about that. You have this target. This is where each time that you build the program or you compile and build and you want to deploy, all the generated packages, things, if it's in Solidity, we call it ABI, but in Solana, we call it ideal. Okay, so this is where they are being dumped. Okay, and you have test. This is where we write some basic test, thing, and this is some Anchor setup things that you needed to set up about Anchor. If it is next, whenever we have to touch it, we'll touch it. Okay, this is gonna be the program for it. So, and also these things are not very much important. I'm going to explain it to you later on, but this is where if there is some configuration that you need to do for your Anchor project in general, you have to these packages are very much needed. Okay, so but I don't think you're going to touch it in this whole process. All right, so and this part is just an SJS application, like you should already be aware of. All right, so that will be it for this particular section. In the next part of this video, I want to jump in. I didn't actually explain this programs folder. So this programs folder, this is where you have the code, the code to your application. This is where we write the smart contract. You can see that here. You can see this hello, you understand, and you can see basic greeting, so this is the VOT program right here. So everything we need is right here. So in the next part of this project, we're going to now go step by step and work on this thing properly. All right, see you in the next part. So in this section, let's prepare this project for our development purpose. So the first thing I want to do is I'm just going to rename some certain things here. So for example, I'm going to rename this folder from basic to VOT. So this is a program that we're working on called VOT. You can have multiple programs here. Okay, so I'm just going to work on this VOT for now. Look at this program, this declare ID. It literally means the program's ID. This is what you're going to use in tracking this particular program on the Solana blockchain. So in the Explorer, you can use that key, to search for that program online if it is deployed. Okay, so I'm going to change this to VOT as well. Okay, and yeah, and I'm also going to come here to this cargo. You see this name, the name of the project, we want to call it VOT and not basic, so I'm going to say VOT. Okay, so now let's explain some certain things. You see this cargo.toml. Okay, this is like where you install your package.json. If it is JavaScript, it's equivalent to your package.json, but for Rust, platform. This is where you install the package that you're going to be using. So what we're installing on this case is, you can see that is Anchor language. Okay, the Anchor platform. This is what we installed. So you can see that it is installed already, and that's the only dependency that we have for this project. Okay, so yeah, and here, this is where you're going to spend most of your time inside this place right here. This is where we spend most of our time for this program. So we have this. So once we also change this to VOT, you can see this ID is the same thing as this ID. So we want to make sure that is in alignment. Call it VOT. Okay, as well, so that when we are building and deploying, there will not be a confusion in the naming structure. All right, so here we have it, and you run. Let me end this. You run you run Anchor build, but you're going to have to go into the Anchor directory, because it doesn't recognize Anchor in the root of the project. So you want to say cd Anchor. All right, so at this point you can then run Anchor build. And the first time you're building is going to take some time because it's doing a lot of massive compilation, getting all the packages together. So you're just going to have to give it some time. So this has been built successfully. If I run this build again, you can see it just went pretty fast. Okay, so here is saying Anchor Lang version and the current CLI version don't match. This can lead to unwanted behavior. So we can solve this by bumping this, save that, and because I already have that CLI installed, so this quickly just went on. So let me run that again, build. You can see that build process just went straight forward, no delay, no need for that. So then you can deploy by saying anchor deploy if you want to deploy this, but you need the blockchain to be active so that you can have it up and running. And to do that, when you installed Solana, it also helped you to install something called Solana validator node. So if I run Solana dash validator dash node, I want to put this reset flag so that in case I have to close it and run it again, it can start from scratch. So I actually made a mistake. It's not Solana node validator, it's test validator. Okay, so you have test validator, you see it's running here. All right, so now this is running, but there are some things that you need to know, which is the configuration get. So I'm going to run this piece of code here. So say Solana config get. Okay, so it literally tells you which blockchain network your computer is pointed to. Like you can see, this is local network, so my own is pointed to the local network, so it means that it's going to connect to this validator node here. So but let's say you want to take it to DevNet, you can run this code. Let's see that in action. All right, so it's been sent to DevNet. You can also have it on mainnet beta. Okay, so and if you run that get again, you can see that this is mainnet. So anyone you sent it to, that is the one that is going to be default to. So I want it to be local host by default. So this will be the local host, and I could work with this. You can see that local host right here. So we're good now, and there's also something that you should take note of, which is creating a key. You need a keygen so that you can interact with the network. So you can run this Solana new, and the first time you run it, it's going to generate a keygen for you. So you can always run that. So I say Solana keygen new. Say refusing to override the existing one. I have one already here. I don't know if this is still active. Okay, so if I anchor version, so let's try it as Solana config get. You can see that this is the mainnet, so I'm going to change it to local. Solana config set. What am I setting again? I'm setting the URL. Okay, so say set -- URL to localhost, and now it's in localhost. If I do that get again, you can see that is the localhost right here. So why I'm doing all this is because this would be like your interface if you're freshly installing Solana. So you can do Solana -keygen, and say new. can see you're asking it to generate a new key pair. But before I do that, if I do Solana address here, you see there is no default address, so we need to generate an address first. So let's run that keygen, and it's asking me to enter a BIP phrase, but I'm not going to do anything like that. I'm just going to click enter. So you can see now that this is my public key and this is the seed phrase. Okay, this is the seed phrase right here that generates this key. So at this point, if I run Solana address, you can see that address is there, is serving in that default location. What if I try to create a new keygen? You see that is where we are. It's going to refuse to override it, but you can add this false flag to it. Okay, so if I say new dash dash, or if I say new, let me check the address again. So say new dash dash false, and I'm going to generate a new one. You can see the public key now, it's going to be different from this. So if I run this Solana address, you can see this is my address. So those things, they just need to be there, so that we will not have any issue. So I'll say Solana address. You can see this is my address here. This is great. So let's do anchor, deploy, because we've built something before, but I normally like combining anchor, build, and then anchor deploy, so that it can run together at once. You can see the built it here, and then it's actually deploying, and each time it deploys, it generates a unique program ID. See, this program ID, what you want to do is to make sure that it is the same as this, because if you don't have it the same, it could really mess you up. Okay, so I'm going to find a way and make sure that they are the same, and let's run that again. So you see, this is program ID, everything is the same. So this is like an evidence to you that our package, our entire thing is ready to go, and we are good to start building this Solana application. Okay, so I'm just gonna erase everything and let's start from scratch. So to start this, let us go through this one after the other. Remember that we have Anchor installed in this platform, so you want to use the Anchor language. There are many sub libraries, things that Anchor is needing to write your program for you. Okay, so and to achieve that, we have this thing called Prelude. So if I say use Anchor language, and this is how namespacing is done, it's because it's modular. This thing called Prelude. Prelude is like, it has all the basic things that you need to build your Anchor. So it's more like the preamble, packages that is required to build an Anchor application. So you also want to access everything in this Prelude by putting this star. Please, the rules of Anchor is basically Rust. So every Rust rule is applicable to your Anchor program. So I'm going to need that, and we're going to need more things later on, but for now, let's focus on what is needed. So this, I'm going to say public. Remember, we have public. We discussed that in the subsequent course that we did before on Rust, which is the foundational course. And we want to, before we even come here, we want to say declare ID. This declare ID is the ID, the program ID, how you're going to use in accessing it on the web. So for example, here, if I search here, whenever I deploy, if I search this, I want to be able to find that program details here. So this is the program ID that I'm trying to declare. So, and it has to be a string, it has to be unique. Okay, so have it, added here. I need a public. This is like the entry module, like the main module. That's why it's called lib. Okay, this is the main what's it called again? The entry file to your Anchor program. Okay, this is your entry file, and this is your entry function. So call it mod, call it vote. All right, and inside there, this is where everything is going to be bundled up to. All right, so you want to say use super and everything that belongs to super. So basically you're using everything that came from this preload. Okay. Okay, so currently this is just a regular Rust function. Okay, no, sorry, this is just a regular Rust module. All right, a regular Rust module declaration. But for you to make it anchor based, you simply do that by invoking this anchor macro, okay, called program. So this is a macro, and you should understand that all these anchor features will be accessed via the macro. So the macro basically provides some codes that modifies the behavior of this function of this module by providing the codes that are related to the Solana package. the anchor package. So this thing is coming from the anchor language, and it helps to modify this module into an anchor module. So it's a conversion. This basically just translates it into anchor, and when we are compiling this, we automatically manage how the IDL, which is basically the ABI, okay, is generated and all of that. So just know that this is important, and it has to be available here, and each Solana program must come with this. Okay, so what we need to do is, so I'm going to come back to this SVG, please. So we're going to have to create a function that can create a poll for us, another function that can register a candidate for us, and another function that can help users to vote once per candidate per poll. Okay, and we also want to find a way of initializing the counter, and also initializing the registration function. So we have about 1, 2, 3, 4 functions that we need to work on. All right, so to do that, I will say public function is indicated with fn, of course. I call this initialize. Okay, so and this will return a result, and the result will either be okay or error. Remember when we're doing options and results in the previous course. So we'll say okay, this is what we want to return. There are going to be a lot of initial error box and all of those things then, but let's don't freak out about it. But we're going to need something called context, okay, which is CTX, which is for context, and say context. Okay, now this context, we don't yet have context is for every function that we're going to create, it's going to have a context, okay, and this context is kind of like a structure. You're giving Rust an idea what the requirement for anybody calling this function, what is going to be required for calling or initializing this function. Okay, so this is Anchor's way of building program. You always need that context to be part of your function. So we need to write that context, and in this case it's going to be called initialize. Okay, initialize. Okay, so it's going to be called initialize. We don't yet have it now, so we need to create it ourselves. So let's create it, and I will need you to be very comfortable in this format, which Anchor really work. This is how it works, okay, on Anchor. So this initialize is basically a struct. It's basically a struct, and how you how you define it. Okay, so remember how I told you that everything, every transaction or anything you create inside this, every write operation, ends up having a PDA. Okay, a PDA is program derived, address, and that program derived address is part of the context. Okay, that is how we form the formation of this context called initialize. Is you creating the framework on the ingredients that makes up for anybody that is accessing this function, and also the product that will be created or the data that will be created out of this initialization. So this is how we work on it. Okay, so just go with me here. We're going to come back. So we say struct. This is called initialize, and so this is not all good yet. So first of all, you want to typecast it in this thing called info. Okay, now this info is part of another macro that comes with that comes with Solana anchor. So how you access that macro is by saying of course, like this, always say derive say accounts. Okay, so because this basically is like an account. It's going to be crazy initially, but once you flow, you understand the rhythm, you understand that each function has an account system, where you specify what will be made up of any data that will come out of that function. So this is just how it is in Solana. So we have this info here. So first of all, we want this pub user. So this is the person that is calling this function. It's going to be the signer, and the signer is going to have this info as well. Okay, so we're assigning this info to this signer. So the information that is coming from this context. So this context we give all this information to us. In the contract, we can have access to all those information. Okay, so this is the user, and we want to be able to mutate this user because there will be multiple users coming in. So we want to say, and you do that again with macro base. So you say account. Okay, just don't freak out. Say mute. So you're giving this particular user more context by saying that this account called user is going to be a mutation. So this signer here, we didn't need to create it because it comes with the anchor program. So this anchor program understands who the signer is, which is the authorizer of this transaction, the person that is deploying this transaction or this package on the web. All right, so we also will need another one called public system program. Okay, so we're going to call that program, and this program is going to have the information about this and also this system. Okay, so just switch on your pattern recognition right here. Okay, because there is no way, if you've never built anything on Solana, anchor framework, there is no way you're going to know all these things, but you can understand the pattern that I'm creating here, and then you replicate something like that, and by the use of that pattern you understand how this works here. So I want to create another account called counter. Okay, so counter is going to be an account, and this account is going to hold information about how many number of polls that we have on our platform. So this here right now, what we're doing here is equivalent to this here. This is what we're doing. We're creating this counter. Okay, so an account holds data. Okay, an account holds data. So whenever you see anything such as this, thing called account attached to a key, that means it's basically a storage location. Okay, something that we use to keep track of data. Okay, so this is an account, and of course each time you create it, make sure you put this first one, a single quote in front of it. Okay, it's weird, but you have to just put that single quote in front of it. All right, and the next thing you want to do is which data type, okay, will this counter be made of? Okay, which data type? And the data type you want to do is based on a struct, okay, another struct that you have to define. So I'm going to come below here and define that struct. I'll say public struct, and this struct is going to be called counter. Okay, and this counter, we have one key called count, and that is going to be unsigned integer 64. So this is the size of the variable that is going to be made up of this counter. And of course, this counter is an account, or you can call it a state. Okay, you can call it a state, like a state variable. All right, so just think about it like a state variable, and you want to make sure that you add this macro because you're dealing with Solana here, so everything has to be conform to that Solana standard. So this is an account, okay, a framework. So this counter here, I'm also going to now include it here, right here. Say counter. Okay, so I save this. You can see there is no error right here. So this, you're saying that we want to initialize, want to give this context, this function, information about these various things, information about the user who is calling it, information about the system program, information about this counter, okay, that we keep track of this data, this storage location account that we keep track of all the polls that are created in our platform. Okay, but there is more, we need to describe this counter more. Okay, this is not enough for describing this counter account. So what would be the behavior of this account? So we do that by using another anchor what's it called, macro, to describe it. So you see, everything in Anchor programming languages always have to do with macro defining macro. This is how the macro is defined. This macro defines how this thing will behave, so that when building compilation and these things make sense to the Anchor programming language itself. So we want to initialize this. So init means that we want to create, this account if it doesn't already exist. All right, so if it doesn't exist, we want to create it. I want to say the payer, because whom will be calling this function will be the payer. So we want to say the user is the payer here. We want to also say that the space, okay, the space that is going to be provided on the platform is going to be like 8 bits, plus another 8 bits. Okay, we do this, but in this case we want to make this a general listen. So we want to say something like, want to define a constant, public constant called anchor discriminator size. Okay, discriminator size, which we want it to be general, is going to be based on use size. Okay, and the size will be 8 bits. All right, so this anchor discriminator size want it to be general, so that we won't have to be hard coding values here. So this will be anchor discriminator size plus 8 bits. So that will be for the size of, or the space that this counter account is going to occupy in our program. So next thing you want to add here, please pay attention to all these patterns. Okay, this will be seed. This seed is responsible for determining how the program derived address is going to look like, for this particular program. The program derived address is, just a regular address key, just like with this one. So this seed is very important because it helps to, make that a reality. So we say B, you put B here, and then you put, it's going to be based on this word called counter. All right, so we're basing it on that. And then lastly, we have this thing called bump. So it's not seed, but seeds, okay? So we now have this thing called bumps. So these bumps is an insurance policy, basically, to ensure that the address stays between a certain range, or something called elliptic curve. It doesn't make any sense, and you really don't need to know the real reason, but just understand that this bump here, ensures that this account program derived address stays within a certain standard. You understand that? It's a certain range, so that it will not be misrepresented as a program address. So it helps you to remain unique. Okay, it helps you to remain unique in a certain range. Okay, so what I will reference it to is like this bump. If it is like oranges, so these seeds are like orange, orange. We have green, we have yellow orange, and we have orange that is in orange color. So if you want it to be green, okay, all these seeds that are being produced, to the program address to look like a green color. So these bumps, helps that to retain that green color style of, seed generation. So that is the best I can help to describe it right now. But let's just get into the, the next thing. So this helps to define the characteristics of this counter, okay? And we also need this, we need to duplicate this, we also need another one for registration. Remember, we have not only counter, but also have registrations, okay, to keep count of how many candidates that have been registered. So when you want to do something similar to that, so it's just very simple, straightforward. We're going to duplicate this as well. Call this registrations. Registrations. But I think I've already spelled it this way, so I want to retain this way. Registration. Okay, so registrations. Okay, so I want to use that. This will be registrations. Okay, and you want to paste this here. So, and you want to call this registrations. So this will keep count of all the registrations that have been done on this platform. And with that, you can come here, we can then initialize this. This is the first function. Remember why it is called initialize. This will be the first function that we want to execute before we start, being able to create a poll, be able to vote on a poll, being able to create or register a candidate. So all these things are required, like that, the basic things that we need to have set. We need to be able to have that a counter is created. So that is why we're having this built this way. So now, first thing you want to say, let counter equal to, a mutable reference of this CTX, which is the context, because we want to modify some things on it. That's why we're calling it a mutable reference. If we just want to access information, we will not need to put this mut, okay, this mutation in front of it. So we're calling this mutable reference, and I've already taught all these things. The principle of borrowing and ownership in the previous course that we just learned about Rust. Okay, so ctx dot, you want to access account. You can see all this information that are here. So I'm going to say account. Okay, this ctx dot account. When I call on the account, you can see that I can have access to this counter here. You see this user. Okay, this is an account here called user. These are various accounts that are made up of this initialize. We have this counter, we have this registration, and we have this system program. All of those things are listed here. You see, this is one thing you must understand about that. So I'm going to grab this counter, okay, and I want to initialize it by saying counter dot count. It has that dot count data inside of it. So I want to initialize it to be 0. So by default it has to be 0. And I also want to do something similar for the registration. Okay, so I'm going to call on these registrations and let's grab that. Okay, so with this we've been able to initialize our program. Okay, so I hope that was not so complicated, but at this point, if you run anchor build, you want to run this so that if there is any error, you can easily know that you can see that the compilation was all correct and nothing has been broken. So in the next part of this video, we'll start creating a poll. I'm going to show you how you can create a poll. Okay, so let's do that in the next part of this video. All right, so let us work on the ability to create a poll. Okay, so as of now, you've seen the pattern recognition for creating a function, for making any function that accept parameters. For doing function, you create the function has a context, and the context have a data type or a structure, and that structure is defined based on the rules of anchor, which has macros that defines accounts, different accounts that is going to be part of that structure. Okay, and basically that is what it is. Okay, so let's create another function. This one is going to be called you can say public create public function fn create poll. All right, so in creating a poll, you know the rule. You always want to return a result. Of course, you're going to add this context here. Context is always by default. For now, I'm going to just say something like this. For now, put okay here, and want to pass in some other parameters that we're going to be requiring from the user, which include the description, which will be like a string. So you see, I'm going to use a string data type. All this has already been, I've already taught you how to do this in the previous course. These are data types and these are parameters. Okay, so we need a start date, okay, which is going to be U64. So this is the date that this poll unit is going to start receiving some electoral voting. And we have the end date. So this is when it expires. Okay, so these are the various things that we're going to need. So this is for the function. Now let's define the parameters that are part of it. I'm going to just close this once for a moment. Okay, so I'll come here, close this as well. So I'll come here, I will call this create poll. So I'm sure you start understanding the pattern recognition very soon. So this is public struct called create poll. See, it's a little bit different from the other one, and so the drill is exactly the same thing as this. So we're gonna make sure that we typecast that here. Okay, so is going to provide some info. This, of course, this information, is coming from this macro here. So we're doing this save. So now we want to make sure we pass that here. I'm sure it's going to give us some errors. So this is context create poll. So let's define some information. Of course, this create poll is going to have something similar to this. We need an account, the user. We need to know whom is calling this particular method. So this is the user. We need that user. We also need an account for, we want to create a poll, an account for poll. So this is going to be public, poll, and that is called account. Okay, so remember the tree is going to be info. It's just almost exactly the way we created this. Let me just copy this and bring it here, so we don't need to repeat ourselves. So we're going to say account. Let me just do this here. So say poll. All right, and for now let's save it. So we have poll here. So we have poll which will be created, on initialize on once this function is called. It to be created if it doesn't exist, and this is going to be the pair. The space is going to be this anchor discriminator plus. For now, let us leave it like this, and then the seed is going to be different. Okay, it's going to be different. It's going to be based on, we have this counter here. Okay, so it's going to be based on this counter data type. Okay, this counter is going to be based on this counter we created here before, this account here. So we're going to have to access that. And to access that, I think I could just copy this. Let's copy this again. Come here. I'm gonna come below, paste this, and let's remove some certain things or modify some things. So remember, this is based on counter. The seed is going to be counter. We don't need space on this one, and we don't need a pair here. We need a mute. Okay, so these are the information that makes for counter. All right, so and then for me to generate a seed for a poll, because each poll need a program derived address, right? So, and the program derived address is based on this seed. Now, this is a static seed, okay, which is going to be like, if we put it like this, it's going to be always that program derived address, that particular key that it generates it's not going to change. But we want to work based on a dynamic seed, because each poll is going to be different. So we want to differentiate each poll from the other, and we use seed to do that. So in this point here, I want to access this counter here. I'll say counter, okay, dot count, okay, and say dot to Lee. This is left Indian. There's just a certain keyword like that, but it's just some low-level code. Okay, bytes, and you convert this to a reference.ref. Okay, so this will give us a dynamic or a different seed every single time we're creating it. And please, you know that since the first time, you know that when we are giving a poll ID, we don't give the poll ID doesn't start from 0, it starts from 1. So the very first poll, is going to be 1 be 0 by default. So except we increment it, and we're going to increment it here later on. But if we keep it like this, it's gonna create an error. So, but for now, let's leave it this way. I'm going to visit it back again. Right now, I want to work on this, okay? Because these are the things that I will need for creating an account, a pool account, okay? To store a pool data, this is the thing that we need. But this is going to be different, of course, because we're not dealing with counter, we're dealing with pool right here. So to get a pool, I'm going to come here and say public struct, and it's going to be called pool, and of course it's going to have this information. Is an account, of course, and then want to also give it another macro called derive init space. So this is init space is used to calculate the space that each pool is going to have by default, okay? So we don't need to know it offhand. So it is used to determine the space that each data, okay, based on the content that is coming, each pool, the data of a pool, the space that is going to take on the blockchain. So this is used in deriving or in determining that space. Okay, now in this pool here, I need a public ID. So this is going to be the pool ID. It's going to be on sign integer 64. Okay, I'm also going to need another one called description, public description, which is going to be a string. Okay, now a string needs to be, because it can be indefinite, okay, it needs to be predetermined, like the maximum size that is going to contain. So I want to keep it around max. Call this this is another macro, so you call it max. I think it's called max length. Okay, max length, and you specify the max length that the description is going to have. I want it to have 280. Okay, so I also want a start time. Remember, a poll has a start date, okay, which is U64, and then it has an end date as well. So it's also going to have number of candidates, so I'm going to say candidates. Okay, so this is each poll, this is the structure of the account of the poll. Each poll is going to contain all this information. So now I'm going to use that to say this poll now is going to be this, and we want to say that the poll want to dynamically determine the space here. Instead of adding just 8, we're going to dynamically access this space here. So we'll want to say init underscore space. Okay, so let's continue. This is showing this error because we've not finished. We're not done with this, so we need to add this system program. This system program we normally do add, which is this: define an account for it. So that will be the last account here. You see that error is gone. So this is what makes for you to create a poll. Okay, these are the data, the information that is gathered, all right, to create a poll. So now at this point, we can then come to create this poll. Okay, so I'll come here. What do I need first? First, I need to check if the start date, if the start date is greater than or equal to the end date, then because the start date cannot be greater than the end date, okay, it has to be greater, the end date has to be greater than the start date. Okay, so we want to report an error if this is a thing. So I want to say run return error. All right, remember it's going to be a result, and a result can either be an error or an okay. So at this point, we can return this, but there's no error inside of it. So let's create the error. There's a way we create error here. So I'm going to help you. Let's get some errors created. So I'm going to say error is going to be based on enum. It's not struct enum. So we'll call this error code. And an error code is based on the implementation of error. So there's a macro for that as well. Call it errors, error code underscore code. So now you want to add the first error. So we'll say invalidate. Okay, so this is one error code. Invalidate. So the date is not valid if it is, and you want to put the message as well, because you want to add a message. So the message will be like the start date. The message is based on the macro. So the macro is called message MSG. Okay, sorry, MSG. All right, so MSG then supply, in a parenthesis, you supply the error code or message that you are trying to inform the user. This is going to be very useful when you're running this, and if it encounters this error code, it's going to be reported on the terminal. So you can say start date cannot be greater than the end date. So this is the error that I want to report. So we can come back here. So if there is an error, we want that is associated with a start date greater than an end date, then we want to say this error, access the error code, which is there below, and we call on invalidate dot info into, I have to say dot into, to apply it. So right now I'm just going to put all these things. If you want to tell the compiler that you've not used this yet, okay, I'm using these ones are not yet used, then you need to put underscore in front of them so that it will not give a complaint. I would like to build this to see everything. So everything is okay. So this error code is catching this properly. So we are in good position. So now, this we run if there is any error, if the dates are not aligning. So I want to grab the counter. Remember, this is how you create a counter. So I can grab this counter here, the same way. I'll call on this, because remember, if I call on this account here, so I'm going to unhold this. So we have CTX. You see, this account has counter, pool, program, user. Okay, just like we defined it here, you have user, pool, counter, and program, system program. So we want to access the counter, and in accessing the counter, I don't want to define it as 1, but I want to increment it by 1. All right. So I want to increment this counter by 1 so that the first ID of the pool will be 1. Now, you see, this seed is not going to be correct if we do not also make provision for that change. Okay, so instead of it just being that, I want to add +1 here as well, so that there will be an alignment and I will not be having some seed error. That error is very crazy. I spent quite a lot of time mastering the idea behind mismatched seed in Solana anchor development is a great crime. So you need to understand how not to commit that crime, and that is why I'm taking this time to package it this way. So I've increased the counter by 1. Then I will create a pool. So let's also get a pool. Say pool is going to be equal to immutable account of that pool. So say ctx.account call on that pool. Okay, now that we have that pool, we want to say this pool dot ID. We want to access the ID of the pool. We want to say this pool is going to be this counter dot count. Okay, and want poll dot description is going to be this description here. So I'm going to call this description and pass it over here. Okay. All right. So we want to also call the start and the end. Okay. So I want to say start. I want to say end. Now the candidates, let's define it to be 0 by default. Candidates, which should be 0 by default. Candidates 0 by default. So all right, so with this, and you can say okay, so this helps you to create a poll. All right, that isn't so difficult, is it? So this is how you create a poll, in all that. I think the most challenging part, that I personally faced was the idea of organizing these things here could get you so much confused. But if you understand this pattern, you understand the pattern, such as if you're going to be creating content, you understand if it is an entity that is going to be created over and over again, then you have to initialize it, even though it's just once, just like you have here, where we only are creating this counter program, account once. We had that init, so the init is there for some certain reasons, but if it's to access the information, you and modify the content of it, you just need to add, you don't need to initialize it, you just need to access it by passing this mode here. So you have to study this idea. You need to get the pattern recognition to structure this thing very well. Okay, so this is just a dynamic space which you can add as a macro here, and it basically does that for you by default. So that is what it takes to create a polling unit in this program. So in the next part of this video, I'm going to show you how to create a candidate or register a candidate in a poll. So before we proceed to this part, I would like to show you see how straightforward it is with actually building the function. The function is not complicated, it's just straightforward, with basic programming, tenants. But the only part that has to look a little bit complicated is this derivation account. So this derivation, this is how these are the data that you use to communicate with this function. Okay, so it's just like that. Just understand that pattern and you'll be good. So let's create another function. We're going to call this function candidate registration. So I'm going to copy this. So we have this, and we'll call this register candidate. Register candidate, and it's going to require a context. It's going to require a polling ID, and it's going to require a name. So poll ID is going to be so these are what is going to require. We're going to require to create to register a candidate, but of course you want to by default make that okay, accessible right there. So there we have it. So to create, for now, we need to build this context, the context for registering a candidate. So I'm going to copy this and let's come here. I think we may just need to we can just duplicate this and modify it so that we won't have to be writing everything from scratch. So I'll come here, I'll do this, I'll say register candidate, let's call it register candidate. Okay, so and of course this is going to be a derived account, so you need to make sure that it's having that macro on top of it. There is another thing, okay, to create a poll, if you look here, to register a candidate, I need the poll ID. Okay, the poll ID is required, to register a candidate. So there's a way for me to get that here, because I can't just get it straight from these. I can't access these poll ID from here. Okay, but I can access it by passing it here. There's a way you pass it. It's called instructions. So there's another macro called instruction, and that instruction contains some parameters that you want to pass in. So I want to pass poll ID, which is going to be this data type. So this is the only instruction I want to pass, but for this one I can pass as many as I want, but I want this because this is going to help me to build the seed. I want to build the seed in a different way. Okay, so in registering a candidate, I'm going to need this. Of course, I'm not going to change that, so user is always going to be there, and I need the poll. Okay, the poll, I want the poll, but this time I'm not creating the poll. You understand? I'm only accessing the value. If I was creating it, I'm going to need this init, and I'm going to need this pair. Okay, and I'm going to need this space, but I don't need all that. I just need to modify it a little bit. So just going to be a modification, because at the end of the day, I want to increase the number of candidates that this particular poll has. So I have to pass this mutation principle on it. Now the seed is not going to be generated or gotten through this means. Rather, the seed is going to be gotten through this poll ID that I'm passing. Okay, so that is how I get the the seed of it, get the seed or the program derived address. Remember here that in creating this, you see that this is the poll ID. That is just how I got the seed. The seed is created. So I have to also pass in that seed method, the method for making sure that the seed is exactly how it is. So these little things that I'm telling you can frustrate you if you don't get it right. So you got to pay attention very well here, that this seed is very important to accurately deriving the content or accessing the data of each poll. You understand? Or to even create a poll properly. So all that is very important that you take note of them. So that's the main reason why I'm passing this poll ID inside there, is for me to derive the seed properly. So this is how I get my seed for poll and make sure that I'm accessing the poll properly. I also want to create a candidate. I'm not accessing a candidate this time. I'm creating one. So I'm going to come here and let me copy this whole thing. Okay, copy this whole thing here. So, and just below here, I'm going to paste it here. So I'll call this one, call it candidate, this account. So this candidate is going to be based on, and remember here that in this initialization space, we actually created another one called where are you? Initialization, where are you? So this one here, we created this as well, called registration, right? So we want to also grab this registration too. Okay, so there's a reason behind it. Okay, so let's take it slow. All right, for now I want to be able to create a candidate if it does not exist, and that is the primary reason why we're creating these structures, to be able to create a candidate. So if a candidate does not exist, we want to create it, and the user that is creating that candidate or wants to be a candidate for a poll will be the one to pay for that transaction. Will be the owner, is the payer, basically paying for the transaction. And the space that is going to occupy is going to be based on this poll. We don't yet have a candidate, so we have to define what a candidate is. And I also want to define, so I want to change this to here. To change that successfully, I have to define what a candidate is. So a candidate, we can basically just copy the same thing here with an account. So we'll call this candidate. So these are the characteristics of a candidate. Candidate has a poll ID, or it has a candidate ID, and a candidate also have a poll ID, call it poll. So because a candidate belongs to a poll, okay, and it has its own ID as well, so that you can differentiate it from other candidates. So, and a candidate has a name. So this name, I'm going to give it a max length of 32. Okay. So, and a candidate has number of votes. All right. The number of votes that has been given to him, that people have voted for him, so we'll call it votes. So these are the information that a candidate, entails. So I'm going to copy this candidate now. This here, this will be the definition of a candidate, and this will be the space. Because of this macro that we put, that we can dynamically, determine the space that should be made available for each candidate as it's being created. Okay, so that is cool. But now you can use this counter, because this counter is talking about registration. It's talking about poll creation. So we need to use registration counter instead. Okay, but we can't. We don't yet have registration. We only have counter here. Okay, we only have counter here. We need to change that to registration. All right, so I want to say registration, so we can just find it so that we won't make mistake in the naming structure. Be in this initialize, so this registrations here. So I'm coming back here. This will be registrations, and I could use that registrations struct, which is this one, to access here. So now here we go. Now we can then access this registration here. I will keep this logic the same because I want to maintain that same flow. Is always going to be +1 and not starting from 0. So those are the things. Those are just a few modifications, the changes that we're making. These are the only thing we're making here. So of course here you want to call it registrations. You don't want to call it if you're accessing registrations, you don't want to call it I think the only thing you want to do is to just, we can keep it this way, but it's not necessary. I think we can just only use mut for mutation, because we're just making some modifications on it. That is just all we need to do about it. Okay, so yeah, we're gonna just keep it this way, and we can then use this register candidate derivation account to replace here. Okay, so now let's work on it. The first thing we want to do to be able to create a candidate. Okay, so I hope you're understanding the flow here. You define the context to which the context here is very important. This context, to define it, which is the definition we give here, and to create any accounts and bring together all the accounts that are necessary to register a candidate under this umbrella. Then you can then utilize it here. So that's just what we're simply doing. So in registering a candidate, we need to know if that polling unit exists, because you can't just register someone out of the blue. So you want to say this poll is going to be equal to immutable reference of this ctx.account.poll. We're accessing poll, but if you look here, we have poll, we have candidate, we have registration, we have system program, we have user. So all of those things are part of it. So I want to say poll. Okay, and in this poll, we want to check first that if don't need this, if the poll ID, this poll I'll call on the ID of it. If it is not equal to, this pool ID that I'm supplying here, this one, if it's not equal to this one, then it should return this error. Okay, I think we can just copy that same style here. So should return this error. Now this is not going to be this error, of course. We're going to have to define our own error in this case. How it's going to be, the error is going to be called pool does not exist. Okay, pool does not exist. So let's add it to our error log, which is here. So this is another struct, pool does not exist. So I'm going to copy that, say pool does not exist or not found. Okay, so I'll come here and replace it here. So this will be the error that will be returned if for any reason that pool is not found. So once the pool is found, we also want to check if we don't already have a candidate like that, because we don't want a candidate to be able to register twice. So a candidate can only register once. So I'm going to do something similar here. I'll copy this. I'll call this, candidate. Okay, and I want to access this candidate here. So now that I have the candidate account, I want to say if this candidate, has registered, there is a key in candidate called has registered. I think I may have skipped that. Yep, I skipped it. So a candidate has a public key called has registered, which should be what? A boolean. So it has registered. So I'll come here and say candidate dot has registered. If this candidate is registered, then it should say you cannot register to type. Candidate has already registered. So I'm going to come here and add this address. So this is the error code, candidate already registered. Okay, and that will become the error here. So this is the second error that we're checking for, condition we're checking for. So after that, if these two conditions are met successfully, then I want to then register a new user. So I want to say this registration, I want to increment this registration counter. All right, so I'll come here, paste it, registration counter plus equal to 1. So I'll increment it by 1 so that I can use that ID to create a new candidate. So I'll then say candidate here dot access the ID, CID, which will be this registration dot counter. Okay, and this candidate, the polling unit, so say poll ID is gonna be this poll ID that I'm receiving from the parameter here. And we also need the name of the candidate is gonna be this one that is coming from this parameter, this name, and want to change the status from because it was not registered before. Okay, has not registered before, so this time I want to say has registered is true. Okay, so this candidate has registered. So this is basically it, and at this point you'll be able to register a new candidate. Simple, easy, straightforward. So this part is always very easy and straightforward. It's just this part that you just need to master, pattern recognition. I will really, tell you that you should study this part, study how this angle is being done, why this thing is like this and why it's like that. So you need to research it and gain mastery of it. Once you understand this angle of it, then it will not be a big deal for you to master any other thing, in building of this smart contract in this Anchor framework. So that will be it for this part. In the next aspect of this, I'm going to show you how you can create the voting, function, the function that will be responsible for voting, for a candidate. So let's see in the next part of this video. Okay, so let's get on into the last function here. I'll call this vote, simply vote. Okay, so and to vote, we'll say okay, return okay. And to vote, you will need the poll ID, you will need the CID as well. The CID is the what's it called? The candidate ID that you want to vote for. So these are the things that is required for you to successfully vote. Okay, so but we need to create a context for this vote. Okay, it's going to be each one of these things have their own context. Okay, so I'm going to call it vote candidate. Okay, so we can basically just duplicate this line, copy it, come here below, we'll call this vote candidate. So to vote a candidate, you will need to pass, this time around we're not only passing the poll ID, but we're also going to be passing the candidate ID as well. So those two are needed to formulate the CID. Okay, so this will remain, we have this the same, and this will get you a poll. And this time around we don't need all this. Okay, we're going to need all this for voting, so I'm just going to duplicate it and call this voter. So this is the voter that you're creating. So basically creating a voter when you're voting. So right here I'm going to remove this because I'm only accessing the information which is based on me mutating. So this place here is going to be based on the CID that I'm getting. So, and there is something that we'll probably have missed that we need to go back to. Yeah, I missed that. So in registering a candidate, we don't only, this is not the only seed that is involved. Okay, in registering a candidate, we also need the poll seed. We need to use the poll as well to the poll ID and the candidate ID will form the seed for that particular one, so that it will be different for each candidate. Okay, so yeah, so that it will be different for each candidate. So this alone is not unique. We want to tie it to that particular poll, so we want to add that line here, and you can basically break this into multiple lines. So these are the seeds that makes for a unique candidate. Okay, so because of this, the way this seed structure is, this is the same thing that we want to do here as well. Here. Okay, so that's the same thing we want to do here, but in a very unique way. So this one will stay, because we're passing that seed ID, so it will generate. But here, instead of doing this, we can then call on this CID, which is this one here. So these two will form the seeds, for that particular candidate. Will help us to retrieve that candidate successfully. Okay, so that is cool. Now we need to come back to this vote. We need to create a vote. Of course, we need all this, and the size of here we'll have to statically type it. We can keep it at 8, or 25. Let's keep it at 25. Okay, and then the seed for this, the seed is going to be, let's modify the seed a little bit. Of course, the seed is also going to be based on this poll ID. Okay, this is going to be one of the seeds. Okay, well, let's break it down. So the seed is going to include a static seed of voter, okay, and you want to make sure that you put B in front of it. So a static seed of voter right there, and plus the poll ID, you understand that, and then plus the user key. So let's say the key of this user, I'm going to convert it as ref as well. So this will be part of the key. So each voter is tied to a poll, so that you can only vote once per poll. And this user key here is making sure that this particular user can only vote once in this poll. Okay, this particular user can only vote once in this poll, so that it prevents double voting. So this alone is very cool. I don't need to write some other complicated logic, because this seed will ensure that if you voted, you cannot vote a second time again. So this is just very fantastic, and I believe in, if it was Solidity or maybe any other programming language, I would have to write a different if-else statement to just make sure that I using checking for whom has voted once. But I'm also going to do that, but this is a prevention mechanism. Okay, so and now we need to create a voter structure, because we don't yet have it. Okay, so who is a voter? How is a voter described? So a voter is just an account, so we can use something. We've been doing a lot of these things. So it's just an account. We can copy something like this, come here, paste it here, call this voter. So a voter has a CID. So this CID refers to the particular candidate that he or she is voting for. The poll ID, okay, refers to the particular poll that this voter is voting and then has voted, which is a Boolean key to determine whether this person has truly voted or not. So that is what makes for a voter. So I'm going to put that here now. So this is a voter. Okay, so at this point we can use this voter. We can use this voter to create a vote, to create a new vote. So let's come here. So inside of here, you want to say this vote candidate, right? So instead of here, we want to access the voter. So we want to say let voter equal to immutable reference of this context, call on the account and grab the voter. So this voter, we want to grab that voter. We also want to grab the candidate and want to grab the polling unit. So we want to grab it all. So we come here. You know that we have candidate here, an account, we created that. So have candidates, any one of the accounts that are here. So you can see we have candidates as an account here. We have voter as an account here, and we also have the poll as an account here. So those are the things we're grabbing. So we also want to grab the poll. So we've gotten those contexts. We want to check for a situation where this candidate has voted. If this candidate has not voted, because you can't vote for, if this candidate has not been registered, so you can't vote for a candidate that has not been registered. So because when you're passing this candidate ID and all that, we need to make sure that the candidate that you're referring to has been registered. So how we know that is we're calling on this. If it's not registered one, remember how we know that this candidate is exactly the same data as this is because of this instruction that is pulling. So this instruction is grabbing a candidate that is based on the seed of the poll and the ID. So it's going to definitely be the accurate, candidate. So we are just making sure that is an accurate candidate. So we want to make sure that this candidate, because we're getting it from the contest, right? So we want to make sure that this candidate, has not, if has been registered, and we want to make sure that this candidate is in this polling unit. Understand? Because not every candidate are in the same polling unit. So I want to say dot poll ID is, if this candidate is not in this unit, okay, then we want to respond with this error code, which is error code. So want to respond with this error code, want to say candidate not registered, candidate not registered. See, candidate is not in the poll. Okay, so come back here. This is what we put here. So that would be one prevention mechanism. What about the second one? Want to check for another prevention mechanism, which is, we don't want a double voting. So we want to say if this voter, okay, this voter right here, has voted. Okay, if the voter has voted, okay, that means it does exist. There is a vote like this, a voter like this. Then want to simply return an error saying that already voted. So first of all, I'm not even sure if it will even get to this point, because the derived program address will not be found. So you can't even, this is so secure. You understand? It's so secure, and that is one of the trademark of Rust. Rust is a very secure language. See the way everything is just bulletproof. You understand? I like that. So I want to say voter already voted. Okay, voter already voted. So you cannot vote twice. So come here. See, voter already voted. Voter cannot vote twice. So come here. That is the message you're passing here. So now that these two conditions have been passed, if the two conditions are passed, then let's create the vote. Okay, so we say let current time equal to, because we want to use this to check on the start time whether it is time for you to vote, because you can't just vote, right? We want to check for the condition whether it's time for you to vote. So we want to call on this clock. All right, say get, this clock is is the time that comes with Anchor or the Rust program. I think Anchor, it comes with Anchor already. So you want to grab the Unix timestamp and you want to convert it or typecast it to be this data type. Okay, because if you don't type, you want to compare with the polling unit, the start time in that polling unit, which is also a 65. So this is not the right data type to make that comparison. So you have to make sure that you put it in the right data type. Okay, and of course this thing is not supposed to be a negative. There is no negative timestamp, so it's supposed to be unsigned integer, in the first place. So at this point, you want to check, do your each if else condition, check for your condition. You want to say this current time. We want to make sure that this current time is less than the time in the polling unit. So, if it is less than the time in the polling unit, that means it's not yet election time. It's not time for you to go and vote. So I want to say this starts if the current time is less than the poll does start, or this current time, okay, is greater than the poll.end. So you're checking for the both extreme, because it has to be in between the start time and the end time. That is the time for voting. Otherwise, you can't vote after it's gone past those two extents. So if it fails in any one of those conditions, you want to say poll not active. Poll not active. So it's not yet time for you to start, doing your polling. That is casting votes. So I'm going to come here, poll not active. Poll is currently not active. And you want to, so this is that is almost that I've touched those various context accounts. So after this, now the next thing is to actually cast the vote. If all those conditions have been fulfilled, it's for us to cast the vote. And to cast the vote is basically to create the voter and assign some information to it. So this voter.poll ID is going to be this poll ID here. We also want to say the CID. Okay, it's going to be this CID. So, and you want to say has voted to be true. Okay, that is cool. But that candidate has number of votes, so we want to also increment that. I want to say candidate dot votes. Okay, I want to say plus equal to 1. All right, so that will increase the number of candidates, the number of votes that particular candidate that we're voting for has. So this will get going. So basically, we've created all the various functions and accounts and derivation strategy or context for our entire program. So it is now time to perform some tests. We need to test out some things and to ensure that everything is in good faith. So let's do that next. Okay, so in testing these functions to verify that everything is working, you have to come to this folder called test. Okay, I have to rename this first to rename it. Okay, it's giving me a little bit of an issue, so I'm going to rename it straight from the folder. Rename it to votee. Okay, so there we have it. We'll rename it to votee right here. So I want to get this. I think I'm going to import it this way. So let me remove all this. Okay, so this is let's do some testing. So first of all, I want to describe. We don't need to import that. Describe, votee, and it's going to be a function. Let's check this package.json to see if everything is available. We have jest here, ts-jest. So this thing is giving us this issue. So let's run this again. Let's run that on the terminal. But this was already present though. I don't know why it's having that unnecessary issue. tsconfig. So it's still having issue. So let's try this as well. That seems not to be the issue. Okay. Alright, so that kind of resolved it because we have like two tsconfig. We have another one here, and that one was just producing some stupid error that was making us a little bit confused. All right, so this is the votee right here. I want to for you to be able to write a test, you need to grab the provider or the network which you want to be interacting with, and it's called provider. So I want to say provider is equal to anchor, this anchor here, this one. I want to call on this anchor here, anchor provider. All right, and dot local. This is the blockchain network that you want to deal with, and you want to say this anchor dot set provider is, you pass in this provider here, so that it will be aware which network that you want to be interacting with, and you want to set workspace. Workspace helps you to know which of the program that you want to work on. So you want to say const program, okay, say anchor dot workspace and call on devotee, depending on which particular program that you wrote. So for mine is devotee, so the target, I don't think I'm supposed to also build this. Let me build that again. Okay, so make sure that everything is built, and remember when something is built, this is where it lives. You can check this type here. You can see devotee. I don't think I need this basic anymore, so I'm going to remove this basic here. It's not part of what we're looking for. We don't need this basic JSON. Deploy, so this is information. So for example, you can see this is the workspace here, so it's accessing that information, and this is like an ABI that contains all the information about the devotee contract that we just finished working on. So we're accessing that devotee right there as the program. So that devotee has information about both the address, metadata, and all the things that you need to know. And for now, we're going to create, okay, let's create the first test, it, and we'll say initialize. This initializes the poll, okay, and this is going to be an asynchronous function. So this unit of test, so let's initialize the poll before you move forward. So the first thing you want to do is say const user is going to be this provider dot wallet. Okay, that will give us the address, the local wallet address for interacting. You need a user for you to be able to initialize or create a poll, create a vote, create a candidate, all of those things. So you need a signer. So that is your signer right there. So we need to derive the PDA, okay, derive the PDA for counter account, and let me show you something here. So this is counter, right? Okay, and if you come back to this initialization, this is how you derive the PDA for counter. Okay, the PDA of counter can be derived by passing this keyword called counter right there. Okay, so let's grab that. Okay, to grab a PDA, which is program derived address for counter account. This is counter account, which is the same as this. Then let's do this. Say const, say counter PDA is equal to, or let's say await. We have something called public key, okay, which comes from Solana Web3. So this public key here, we have this public key. So I'm going to grab that public key, and I'll say dot find program address. Find program address, and in finding that program address, I will need some certain information. The first information I need is I want this counter seed, but you need to express it in buffer. So say buffer, dot from, and then you pass in, that counter. Okay, and You also want to pass in the program ID, the program ID as well, which is this program dot program ID. So these two information will get you the program derived address. Now you have to store that program derived address somewhere. So I want to say const counter PDA. Okay, so this gets us the program derived address, and now we can use this to. We also want you know that when you're initializing, you know that we want to actually initialize a poll, initialize this registration counter and this counter and these registrations, right? So we want to initialize them both. So we need to also do something similar for registrations as well. So I want to call it registrations PDA. So I'm going to copy this and paste it here. For registration, make sure you just copy this keyword and put it here. So basically the same thing here. So now that we have that, we want to attempt to fetch the counter, to know whether counter has already been initialized, before we even proceed. So I want to say attempt to fetch the counter account, skip initialization if it exists. So we want to also skip initialization because we don't want to initialize it 2 times. You only initialize once, or want to call that function only once in the course of this program. So you want to say let counter, because we want to use this to keep track of it. I want to say try catch. So in trying, we want to say counter. This is how we'll call the information, call to await this program dot account dot counter. It's almost the same way that we are accessing this information. You can see here, CTX. Think of it as that program dot account dot counter is almost the same way that we're grabbing that information. And then you want to call dot fetch. This dot fetch, you pass in the PDA. So the counter PDA. So this will grab the counter. All right. So it grabs us the counter, and then we can log out something by saying counter account already exists, because if you can retrieve that, it means that it exists. Okay, so that is what it simply means. So we have counter account already exists with count. With count, then we can actually display how many polls that have been created if it already exists. So that has been initialized, and then we can tell how many polls that is in it already. So counter.count, to string. Sorry, we want to convert that to string. Okay, so if this is the case, okay, if it's already there, but if it's not there, then we need to create it ourselves. Okay, you can see that I didn't have to bother about the registration as well, because we know for sure that if the counter is initialized, the registration is also going to be initialized, so we don't need to check for the both of them at the same time. So at this point, you want to drop a little message here. I want to just say that counter account does not exist, so therefore let's create it, let's initialize it. So counter account does not exist, initializing. All right, so to initialize, you need to call on, say, await. Okay, this is how we speak to the function, this function here. This is how we call on this function, is by saying await this program, this same program that we've been communicating, program here dot RPC. There's a method called RPC. Okay, and in this RPC, you want to call on this initialize. Okay, here, this RPC, there's a method called initialize. Okay, so this method called initialize, we have some information. So for the information is about the account, the details of this account, this counter, the come back here, which is you want to supply all this information. First, you want to supply the user, you want to supply the counter, information. You want to supply these registrations and also the system program. So we want to supply all those information. So we want to say account. All right. These are the various accounts that are there. So we need to supply those information. So I want to say user, for example, which is the first one here. You want to supply this user here. See that? I want to say this user dot public key. So the public key is what you're passing in here. User is user.public key, and make sure that this one is key here, public key. Okay, so you want to make sure that the counter, this is the counter now, the counter account. Say counter is going to be this counter PDA here, this one. So this is how you derive information about the counter. And you want to also do for registrations. So registrations, you want to supply this registration PDA. And lastly, this system program, system program is, if you have one thing you should know is that when it is separated with an underscore in the contract, you need to make sure that you merge it. You use this camel case instead. So this is going to be this program. We want to call on this system program that is coming from Solana Web3 as well, which is the same place as this. Want to call on that. Want to say dot, program ID. Okay, so these are the information that you need to initialize the counter and also initialize this registration number. So once that is initialized, you want to grab that counter again. So after it's initialized, you want to grab this counter. So you want to say something like fetch counter after initialization. All right, fetching counter after initialization. You grab it and you want to just say that it has been initialized. Counter is initialized with count. You drop that count there. So basically that is what it is. You can break this into multiple lines. This formatter is automatically formatting it like that. So after we're done with this try catch, this try block, with this try catch, then we want to proceed to increment, like the next. We know that increment count to predict the next poll ID for PDA. Remember, so that if I'm supplying this seed, remember I'm done with this initialization, but now I'm talking about creating a poll. Okay, so if I want to create a poll, I need to determine this seed very well, because I need to make sure that this seed is accurate in this format as it is here. So for me to do that, I need to know the counter, because when I'm creating a poll, that means the ID will increment by 1. So I have to be targeting the next ID of it. So if I come here and say this PID, which is what I created here. Okay, I've not created it. So let's come back here. So I will say PID, I'll say let PID is going to be any. So this PID here, I will say is equal to this counter dot count. Remember this counter, I initialized it here, so all these assignments are being stored in this counter. So this counter dot count, and there's a method called add that because it's a bn, a big integer, so it has this method for me being able to add some new values to it. So I'm going to add new anchor dot bnb bn. Okay, I want to add 1 so to that id, so the id will be incremented by 1. I'm storing it here for future use. Then I want to then make a program derived address for it as well. So this will be the program derived address for the next pool. Okay, so I'll call it pool PDA. So how do we derive this? So we need to pass in this seed, which is this PDA right here. Okay, this is how we do it. We're going to do it a little bit different. So this PID or pool ID, I want to say to array like. Okay, and then we describe how it's going to look like in that array. It's going to be a buffer based array, and please remember this is converting it to a certain data type, which is this left endian, or I don't know what little endian, okay, byte order. So we want to convert it to that same data type, that little endian. So you have to specify LE here, and it's going to be 8 bits by default, 8. Okay, so this will be the seed that we will also get. This is how you can create this thing successfully. You can replicate the seed successfully. This thing here that I just finished doing is so important. It's very, very important. If you don't do it accurately, then it's going to really, really complain. Okay, and I'm trying to prevent you from suffering that. What if I'm done? So after I'm done, I want to create description. You remember there are some details for creating a pool. So a pool requires description, start date and end date. So I'm going to just create those things. So this is a description test pool, or pool number, that number, days, number, whatever. So I'm going to also have the start date. Okay, the start date, this is the time that this is starting. Okay, but I'm going to make sure that is in big integer format. That is what it is. And the end time as well. So this is going to be the time that it will end by just adding it. I think how many days is this, I don't know exactly, but this is a couple of time that is quite enough, maybe a couple of seconds or so, or minutes, I don't know. So but this is an addition of some time to give it a space for me to literally just test it out to make sure that it's working. All right, so that time it starts and that is when it ends. So let's call the create poll account. So I want to call this method now. So to call it is literally the same method as this. So I'm going to copy this line of code, bring it here, and in this point I'm going to be calling create poll. Now this create poll is not going to be referred this way, it's going to be referred like this. Okay, and now the accounts that should be made up of this create poll will be the user, which is already here. It will be the user, it will be the poll, which we can use the poll PDA. So say poll, it's going to be this poll, sorry. So say poll, which is going to be this poll, poll PDA. Okay, and the counter is also there, which is going to be this counter, which is going to remain the same, and the system program, which is going to remain the same. So this is it. And to verify that we've been able to create it successfully, verify that the poll was created with the correct data, then you want to say const this poll is equal to await, and you call on this program dot account dot poll, then dot fetch. Okay, and then you pass in the pool program derive address. So if that pool was created successfully, it's going to return it for us, like that, and then you'll be able to see it. So, but of course, we haven't passed in these parameters. It's quite important that we do. So just like in the order, which is right here, the order will include description. This is where you pass it description. You need the start and the end. So those are the parameters that you can interact with this. So at this point, we can test it out. Okay. How you run the test, is by saying anchor build, anchor build and deploy. First of all, you make sure that thing is online. Always make sure that you have. Okay, so whenever you have this issue of this issue here, you see failed transaction process and it's giving you so many lines, you just need to restart this particular server. All right, restart it again, end it and restart it. Ctrl+C to end, and then you restart it. So this is back online. So let's run that again, build and deploy. So it is online now with the correct program ID, like you can see here. So now let's test this out. To test this, you say anchor test, but you can put help because there are some things that we need to supply. So for example, I want to skip local validation and I want to skip deployment. I don't want it to redeploy again. And because this test was designed to spin up, when you run anchor test, how it was designed is for it to spin up the blockchain server and deploy the smart contract into it, then run all the tests, then end everything. Okay, so but I have one that is up and running and I don't want to go through that routine. So I have to make sure that this here, when I'm running anchor test, I want to pass in this skip local validator, and I also want to pass in this skip deploy so that it will not keep redeploying every single time. So I run that now, and let's see it in action. Okay, so it seems like I made a mistake, in how I'm spelling this workspace. You can see is spelled wrongly. Workspace is supposed to be the accurate representation, and let's try it again. Okay, so that passed successfully. I almost wasted a lot of time. So you can see was able to create see counter counter account does not exist, so it initialized with 0. Okay, just like we have it on the contract, just like we have it on the contract that should initialize with 0, and also that registration is also initialized at the same time as well. So yeah, so it initialized with 0, like you can see here, and after it initialized, we created a new counter. You can see the details that is returned, which is this is the poll that was returned, this is the BNB time and all that, and the number of candidates 0. So we've been able to test the first case here. Okay, so let's test the second case, which is to register a candidate. So to register a candidate, I'm gonna be a little bit faster. Remember, whenever we initialize this, we create a poll and we actually capture the poll's ID so that we can use it later on. So that is one of the reasons why we have this PID, so that it can be accessed outside of this test. So I want to access it in another test here. So because once it is created, it's already in the blockchain, so we can always access it from there. And like before, you want to grab the user wallet, and you want to grab the poll PDA. Okay, you want to grab the poll PDA, and you can also grab that from here. Look for the poll PDA, which is here. Okay, grab it here, and we'll represent that. Okay, so this is the poll PDA, and we're accessing the PDA from here. So to get the program derived address, and you also want the registration PDA as well. So I'm gonna grab this registration PDA. Okay, so now let me bring this a little bit. Okay, so I'm gonna bring it to this part and close here. So if you want to register a candidate, you come to the register candidate parameter. You see that to register a candidate, we'll need the poll account, we need the candidate account, we need the registration account, we need the system program. So those are the ones that we'll need in this particular session. So I've gotten the poll, which is the poll account, we've gotten the registration account, we've gotten the user as well. It's time for us to get the candidate. Okay, and now to get a candidate, we need to fetch the registrations. We need to first of all fetch the registration. Say regs is equal to await. It's almost the same way that I use in grabbing or the counter here. So I'm going to take something similar here. So let's say regs. Okay, I want to grab the registration. That's what I want to grab, and I want to pass in this registration PDA. Okay, so this will get me all the regs, and I want to extract the CID there. So now the CID has not been created, so I have to create it here as well. So I will have CID, and it's any. So CID, which is the candidate ID that I want to vote for. As of this time, we don't have any candidate yet, so it's a fresh one. It's supposed to be 0 by default. So it's something similar to this, where are you? Right, so here. Okay, something similar to that. So coming here, we're saying this regs, okay, dot count, and we're adding 1 to it because we are predicting the next, program, the next candidate ID to correspond with this. All right, so that's why we're adding 1 to it here, so that it will correspond to this seed, because if that seed is not corresponding, it will fail. Okay, and I'm going to show you a situation where the seeds, they are not accurate, and you see what I'm talking about here. So once we get that, we can then get the candidate name. We know that is part of the parameter, because now that is one of the parameters for registering, a candidate. You need the poll ID and you need the name, but we already have the poll ID here. We have the, the want to create a name. This is the name here, candidate name. It's going to be based on this candidate ID here. And want to find the candidate program address. Okay, so I want to say candidate PDA, and want to call, this is how you get the candidate program address, which is here. You have to simulate this seed structure as well. So to simulate that seed structure, it's more likely to be something like this. So we have PDA. Okay, want this, make sure you break this into multiple lines. Okay, and you also want this as well, because you see this registration.count, plus 1 is exactly equal to this here. So this is how you get, the counter. All right, you get the accurate seed structure here. So this is it, and now I have to come here. We have to now call, on this register candidate method, which is something similar to creating to creating a poll. So I'm just going to copy them. I'm doing that so that I won't have to type everything myself. So here we are. I'm going to call on register candidate, this method, and in this register candidate we need the poll ID, which is PID, and we also need the name, the candidate name here, which is what it is here, and make sure that this thing is correct, candidate PDA. Okay, so what does it take to register a candidate? The user is always there, the poll is needed, the counter is not needed, but what is needed is the candidate. So say candidates, and there's also going to be a registration needed. So candidates, you need to pass the candidate program address, and you need to also pass in the registrations. So you say registrations, you pass the registration PDA here. Okay, so and the system program is also part of it. So this we create or register a candidate for you, then we can retrieve the candidate to verify that everything is working. And how we do that, we can easily just copy the same protocol here, see, verify that the candidate was created with the correct data. So we call on candidate, say await candidate, and fetch the candidate program address. Okay, and then you can drop that. So let us test it out and see if everything is working as expected. So I'm going to run that test again to check and verify the second one. So the first one worked successfully. The second one failed, saying that this registration candidate is not a function. You understand that, because this is not how I'm supposed to call that function. I'm supposed to call it this way, register candidate. Probably that was why it wasn't. Okay, so this is how I'm supposed to call it, register candidate. Okay, so let us run that again. You can see here that we have one already. So this is poll ID 2, so we have like 2 polls right now. So this one that we're going to do is going to be like a third poll. Okay, you see the 2 tests have passed successfully, and you see it was able to create that candidate based on the poll IDs 3. You can see the candidate IDs 1 and all that. So remember that I told you that you have to be very careful with this seed system, okay? Because if you get it wrong, you're going to be wrong, very wrong, okay? You're going to be very wrong. So for example, now let me simulate a situation where you did not accurately predict the seed structure. Let's say, for example, okay, see this is just the count. We want to check if it matches the structure. If the both ID they are not matching, let's see what will happen in this case. So let's run that. So you see that it's failing. It's telling you that what you're supplying, which is the left, does not match the seed that you're supplying, which is the left, does not match. So this is the program derived account. This is the one that you're supplying based on the combination, the erroneous combination that you're having. These 2 combination does not match. The seed of these 2 seed does not produce this result. It produces a different result. So you are going to have a lot of issue if you don't know if you're not addressing this seed structure very well. This is one of the major issue that I had to deal with and gain mastery at. So I'm accurately predicting it according to the same pattern here. You can see the instruction you're given, that code constraint, you understand? And it will tell you which particular place you're violating, the account that is being violated. You can see that is actually candidate's account, anchor error caused by account candidate. Okay, so you know that this is coming from here, or how you are, deriving the program address here. So this is where the problem will be coming from whenever you face something like this. Then you know that what you are supplying is not equal to what you described within the contract itself. So in that case, you look deep. So the problem is to just make sure that you address the seeds properly. So you can see what is saying, that error code is constraint seed. Constraint seed. Number error message, a seed constraint was violated. So basically you did not follow the pattern very well. Okay, so let's run that again to check it out that everything is working. Okay, everything is working. Now there's one more test that we want to do, okay, which is to vote. All right, so let's vote. I'm gonna close this for a moment. So in order to vote for a candidate, you want to grab the program address, right? So this is the program address. I'm going to grab that. Okay, so what else do you want to do? You want to grab the candidate, the candidate PDA as well, which we were able to do, thanks to, this CID method that we established here. So this is the candidate, that candidate was stored here. So this is the candidate right here. You do remember that we saved this candidate here, so it's going to be the accurate candidate. So we don't need to do that mathematical operations to make sure we supply the right one. So now the next one we want to do is to create a PDA for the voter. Okay, remember, if you want to vote, let me bring this back. If you want to vote, you need the user, the poll, the candidate, but the voter as well. The voter has this seed structure, so we need to derive it very well. Okay, so I want to call this voter, PDA. Voter PDA. So to get the voter PDA, what we want to do is supply this buffer. So I'm going to come here, break this into multiple lines, and you want to say buffer dot from, okay, and then you pass in the keyword that you want to also convert to buffer, which is this voter, which correspond with this right here. So here we go, we have this, and this to form the voter PDA for us. We can decide to check if the candidate exists or not, before we vote, but we already know that it exists, so we don't need to go through that process again. So want to then perform, our voting. Okay, in performing the voting, I'm going to just copy this place. Okay, so that will be faster. Copy it here, and we're calling on the vote function. Okay, dot vote. And for you to vote, you need the poll ID and the candidate ID. So those are the two IDs that you need. This is the poll ID and the CID. Okay, which is these two here. And for the PDA, for the accounts that you need to supply, you need to supply you need to supply for poll, you need to supply for candidate, and you don't need registration. What you need is voter. Okay, so you can pass in the voter PDA here. I hope you're understanding this pattern. This is just pattern recognition. It's just pretty straightforward. So with this, you'll be able to vote. Now you want to verify that whom you voted correctly. You want to verify that voting, just like we've always done. So you can copy this line, come here, see, this is voter. Okay, so I want to say account voter, and you pass in the voter PDA here. So this will grab you and just showcase it on the console. So you will probably like to also check how many votes the candidate now have after this user successfully voted. So you can fetch, and verify that. So you can do that by, let's come here, candidates, okay, and you are checking for the candidate votes after voting. Okay, after voting, you want to now say candidate dot vote, dot to string. Okay, so this should be it. So let's test it out right away. We run that, and if there is any error, we'll also know. Okay, it is failing. Say registrations not provided. Registrations not provided. Okay, so let's go back there and check. Did we miss something? Oh, indeed, registration was necessary. So we need to add that. I didn't see that. Totally missed it. It's raining here, so probably you may be hearing some noises. So bear with me. So here we go, and let me provide that registrations here. So we'll grab the registration PDA and supply here. So with that, you see how cool it is. The account registration not provided, so it immediately tells you where the fault is coming from. So let's run that test again. So it is failing. It is saying that a seed constraint was violated. Let's look at the seed constraint and see what is going on. Okay, in voter, so we are violating it in voter. Okay, so definitely that is true. This is not supposed to be how voter should be. See, voter has a poll ID and a user key, which was where we're violating. So we're supposed to say user, this user, right? And you want to grab the public key of that user. Say dot public key of the user, and you want to turn it to buffer. So say to buffer. Okay, so this is the accurate representation of this user key. Okay, this is a public key, and this means user key here as well. So let's check it out again. Run that. Okay, so that succeeded. Okay, correctly. This is really good. So we've been able to test that our entire contract functions, they are working very well. They're working just great. See, sometimes you may find some errors in this third one due to time differences in the blockchain, because the time that it takes. No, not here for the poll. So if the start time and the end time there is too much of a difference, it can also hinder the test results, but it doesn't always happen. I'm just giving you that as a caveat so that you will not feel like the code is erroneous, like you can see it's working, but sometimes it also feels, that I've seen so far, and I don't know why that is behaving like that, but so far everything is working just fine. So that is it for the testing of these codes. Okay, so in the next part of this, I want to take it one more step further. The step that I want to take is to refactoring. I need to teach you how to refactor your code, because if you look right now, this code is just very cumbersome and is becoming very difficult to read and manage. You understand that? So you need to understand how to prepare your code, how to package it very well so that it will not be too disturbing to read and to follow. So I will do that with you in the next part of this video. All right, so to refactor this code, let us go. All right, let's get it done. So sometimes you just need to quit the VS Code and come back again, and everything kind of seems back to their senses. Okay, so we have this folder. Let's create a new folder here. Let's call it constant. Okay, this, if you have some constant variables that you want to keep in one place so that it will be easier, then this will be a great thing. All right, and inside this folder you want to create a file and call it mod, short form for module. Okay, and inside that mod, then you can bring in this, let's call this, cut this out, bring it here. Okay, save that, save this, and of course there will be errors down here below. Okay, so at this point you want to go back and initialize that module. So how we do that, initialize it. So I want to say public module constant. So we initialize that, and want to say use or public use constant access this. So when you access that, then it will be present down here below. So I've shifted that into another file. So that is the first step. That is the first one that I'm doing. And let's create another one. Okay, so let's create another. What about for our errors? We have bulk of errors here. Okay, so all this bunch of errors, we want to shift them into one file. So I'm going to come here to another folder. I'll call this errors. So I could just duplicate this, copy this, and paste here, and call this errors. And inside these errors here, we do something different. I'll cut out this, bring it here, paste in here. But also because these what's it called, these macros, they are coming from the anchor prelude, so you need to make sure that you include it there, otherwise it will have an error. So at this point you can say errors, initialize that. Of course you're going to have these problems as well, so you want to use that, say public use errors. Okay, and you want to call on errors and call on this error code, and you want to get everything. Okay, so that everything will be available. So sorry, you want to get everything here. And not just that, if I remove this now, this will be error free. So I want to grab everywhere that I had to make that and just simplify it this way. So everything inside is error code. So we're shifting some codes. So now we need to create instructions, a folder called instructions, where we'll dump all these instructions. We need to pass it into a folder like that. So let's create a new folder call it instructions. Okay, and inside these instructions I want to create I will be creating different instructions, okay, and of course on a mod file. So let's create a mod file first. So mod.rs. So, and let's create this one called create or initialize. So say initialize.rs. So in the initialize, what we want to bring in is, I just think we'll come back to this. We'll come back to instructions. Let's create a state. Let's create a state first. So say state /mod.rs. So I'm going to create a folder called that, and let's bring in some states into this. So the states are basically accounts. Okay, we have, for example, we have the counter. So I'm going to close these ones then first. So let's come back to here. Remember, we have this counter here. This is a counter, this is an account. So I'm going to cut this and create a state here, call it counter.rs, and paste this. But of course, I have to also bring in this anchor prelude because of this macro that is being used here. So this counter here, we then initialize it inside of this mod. So this, you have to be very meticulous in this process. This cut down your problems. Okay, makes things a lot easier. So we want to initialize this module here. I want to call it counter. Okay, I want to call it counter, and then we also want to use it public use that counter. Okay, after I've done this, I can initialize that state here, create a module for say mod state. Okay, and I can say something like public use state. Okay, and I want to use every element that is found in it. Save that. So you see that if I don't do this, okay, I'm going to have one problem here where one of these things will be complaining about a seed. Okay, see, counter is not present, but once I make it available, I could say state, counter, and then this could work. Okay, but I don't want to do it this way. I'll come back to it. Let it be this way for now. Okay, I'm going to translate all those counters into their various files. So this is registrations. So I'll come here, make sure that I duplicate this. I'll create another file. Let's call it registrations.rs. Now paste this. Make sure that pass this over here. Okay. What else do I need? I need to include it here. Okay. So I think part of the reason is I'm supposed to make sure that I put this like this. Okay. So I need to do this. This will be registrations. I also want to use that registrations. Okay. Yep. You can see that they are actually working now without me having to even touch. So everything is working just fine. It has access to all those states. So all I need now is to just continue doing the same thing. I'll do for polls. So for polls here, you look for polls. Where is polls? You can let's cut account first, okay, and voter. Then we can come here, create a new file, call it voter.rs, then bring this in. So bring voter, save that response there as well. So look for another one. We do candidate, okay, and you create candidate.rs, place it there, and you bring this, make sure it's here, save that, and include this here, candidate, candidate as well, save that. Or else you look for the next, member, which is this poll. That is the next account state. So poll, you come here, create another poll. .rs. Is that save this, make sure you include it here. Say poll, poll, okay, save that. So we have all the states moved into these places. They are no longer here. Things are shortening here, really shortening. So it's now time for us to create the instructions, okay? So for example, we want to come to this initialization instruction. So to create the initialization instruction, you have to first of all come here, you want to copy this initialization script, or you want to cut this out here, bring it here, paste. You also want to make sure that you have this here. Okay, so you cut that one, and what other instruction you want to cut? This initialization instruction. You want to just copy it, don't want to cut it, but just copy it. Okay, so this is the function here, and save. Then you come to this place, you want to do something similar to what you did before. So let me copy this to here, close this, come here, say initialize, and initialize as well. Okay, and you need to now come here to the main and include that. So say instructions, and we need to also use instructions here to use all the instructions. So say instructions. Okay, so that error is gone. So but they're having issue here. Okay, it can't access this. This is a constant, so we need to do something similar to this here. So we want to say how you get around this. You want to say use crat, okay, and you want to access the constants, okay, module. I want to access this size here, okay, and sorry, this is not the place I'm supposed to do that. So I want to do it here. Okay, and that will resolve it. So we got that. And you want to also have access to the state, counter and registration. So to resolve that, you need to do crat, use crat again, and you want to access the states, and you want to access all those states, and that will give you access to these things here. So this is great. And with that, you don't need all this anymore. You will not need everything here anymore. We can streamline this. We don't need the result. We can streamline this and delegate this instruction by saying instructions initialize. Okay, so we can initialize here. So I don't know whether we can boycott this, but the naming convention, we have an issue. So let's keep it this way. So this is instructions. Okay, so that's kind of pretty straightforward, right? So we've reduced. We just make sure that all the instruction code are in one single file, and they are communicating with each other in the various locations. All right, so we also want to do for this create poll, want to send its appropriate stuff into the another file. So I'm going to do this. I'm going to cut this here. You're taking note that this is reducing the lines of code and it's making the project a lot more cleaner to read. So I'm going to come to instructions, say create poll.rs, and you paste this here. Then you make sure that you bring this in. You bring all these things in here because I'm going to need discriminator and I'm going to need the states for poll in our counter. So save that. And then I need to copy this whole thing. You can even remove all these ones here. Okay, copy that whole thing, bring it to this place. Okay, bring it here and initialize that mode. Okay, so you say create poll and create poll. No, and also do create poll. Okay, so now it's complaining about this date. So I also need to bring in the error code for the control, so we can have error control intact. So I'm gonna bring this in here as well. I'm gonna say use crat, and that resolves it. So so that is for this create poll, and here we can minimize this by just saying instruction and then colon this create poll. Okay, and you pass in ctx, you pass in description, you pass in start, you pass in end. Save that. See, everything is on point. What else do you want to do? Okay, so the next thing is we want to take care of this registration, candidate registration. So let's come here. I'm going to copy this line, cut it, save it. Of course, you're going to have an error. You come to instruction, create a new file, call it register underscore candidate .rs, and you paste this, and you, just like you've done before, copy this, bring it in here, and you also do the same thing here. Copy this and remove all this here, and you bring it in here. Okay, and you make sure you include it here, which is register candidate. Save that, and you can see that is taken care of. What else do you want to do for this? Okay, this is still large here, but we're not done here. We need to make sure that have instructions, access the register candidate, and you have CTX, of course, pool ID, and then name. So that is it there, and this is reduced. Now let's make sure that this large one also goes to his own file. Cut this, save this here. You come to this instruction, you create another folder, another file, call it vote.rs, and then you paste this. Okay, so make sure that you bring in this and also copy this entire function and paste here. Okay, so I'll make sure you include it here. Vote and vote. Okay, so there you have it, and colon instruction and vote, CTX, the poll ID and the CID. Remove this here. Okay, so this is pretty much straight, very straight, very straight. So I think we can add some statement here to see, because it's giving this warning unused. See, ambiguous globe re-export all by default. I don't know why that is so, but let's build to see if everything is working just fine. So seed into anchor and say anchor build. Okay, so this has completed its building, and I'm getting a lot of warning, but no errors, but some warnings. And let me try something. So build doesn't solve any problem. Okay, so let's do this. It's giving errors based on this particular, say, ambiguous global re-export. So let's say allow that in this. So in these instructions, there is something that it's struggling with: create, poll, initialize, mod, register candidate. All of these things seems all right, so let's run that and check again. Okay, so everything is all good. I'm going to come here, open another this thing, and run that Solana validator thing, and come and say anchor deploy. Okay, it's generating a new key for us, so we need to make sure that the keys are, the same. So I'm going to come here to this. Where are you? Cargo, anchor, change that as well. Okay, so with this now, I'll redeploy that so that everything will be unanimous. So we're in good shape. So let's test it out and let's run that test again. Anchor. Okay, so anchor test -- skip validator, skip deploy. So let's run that to see. Oops, all of them failed. So let's figure out what is wrong with this. So the problem here that it's complaining, say that declared program ID does not match the actual program ID. So it's saying that this is the declared program ID, that is not matching the one in the blockchain. So best way to do that, to just off this and restart the server. Okay, after you restart the server, you rebuild. Okay, you rebuild anchor build. All right, so after you rebuild, you redeploy. Okay, see this is equivalent to this, and after you redeploy, you perform your test again. Okay, you see our test is complete. So that verifies that every single thing in the contract is working, and this is how you organize your project. So let me open that again and show you how it is. So it's very simple. You have one program called Voti. You can have many there, but for this you have only one. And you see the source. You have a folder for constant, for managing all your constant. You have another module for managing all your errors. You have another modules for managing all your accounts. This kind of breaks down. You see how simple, straightforward it is. Only things that are associated with these accounts are present here. So this is cool. You see for initialization, you see the module arrangement and export. You see, here as well. So everything just divided into smaller piece, which is just very peaceful. Okay, see the account, even as small as this lives in its own module. This lives in its own module. This lives in its own module, and everything is just well calibrated. So this is how you make your project well refactored. Okay, and I hope that has been very useful and instrumental to you. We are not going to do the front end integration in this part, but in the next video or so, we are going to be integrating this back end into our front end application for the next JS project. So till then, I'll see you.